Hello, everybody. Welcome to another lesson. This is our last one for Unit 7, and it is on patterns and shadows. So we're talking about the sun. We're talking about how it could put shadows on Earth from the moon or just from other objects. So it's kind of continuing on from last lesson when we talked about rotation and revolution. So let's get into it. Your only objective is you'll describe how the sun, Earth, and moon interact. So here's our review from last lesson. And so if you remember, we got these two words, these two type of movements that the Earth can do, rotation and revolution. So rotation is like a spinning motion. So if I were to take a basketball and spin it on my finger, and not move it, but just let it spin, that's rotation, okay? But if I were to take that basketball and make it go around my head, or like to carry it around my head, that would be revolution. That's like an orbit. Okay, so that's the difference between those that we learned about last time. So remember those time periods, Earth's revolution, it takes 365 days or 1 year for Earth to revolve around the sun. The Earth's rotation takes 1 day or 24 hours. Okay, that rotation gives us day and night, and Earth rotates on its axis in a west to east direction, which makes it look like the sun is rising in the east and setting in the west. Okay, so that's our view on Earth. These movements also give us our seasons. So Earth's axis is tilted. But first, what is Earth's axis? Well, that's the center that the Earth spins around. So instead of having it just spin perfectly up and down, it is tilted a little bit and it spins at a tilt there. Okay, so obviously we have the sun over here, and day is the side facing the sunlight, and night is where it's all dark. There's no bright sun shining on that side. But let's talk about Earth's seasons. Okay, so this bottom half of Earth is going to get more sunlight this time of year. So that means the bottom is on summer and the top is on winter, just like us right now here in America. We're in winter right now, so we don't get as much sunlight. We get more of the nighttime. We get less daylight hours. But as the Earth goes around the sun, it's going to keep that tilt facing this way. So if my head is the sun and here's Earth, it goes around and now it's over here. Okay, and it's still tilted up towards the top there. Now the top is facing the sun more. So that means the top will be in summer and it'll get more daylight hours. Okay. So we also get the moon phases. So the moon looks different in the sky. Maybe you've noticed this before. And that just depends on where the moon is around Earth. So sometimes we could see the whole circle of a moon, and that means we can see every part of the moon that the sunlight is hitting. But sometimes it looks like the moon is cut in half, like someone ate half of a whole pizza or something like that. And that would just mean that we can only see a part of the moon that the sunlight is hitting. Okay, and there's a great video on all this stuff, so I recommend you go through the Nearpod. This is a good visual of what I was just talking about. So let's just say we're standing here on Earth and we're looking at the sun. And we're looking at the moon. Okay, so this is why it looks like the moon is in half sometimes, because this side of the moon is lit up from the sun, but we can only see the half of the moon that's facing Earth. So that's why it'll only look like a half moon. Okay, and there's a great moon phase simulation here as well. That explains what I was just talking about. Another interaction between the Earth, Sun, and Moon is an eclipse. So an eclipse is when the Earth, Sun, and Moon line up perfectly. So a lunar eclipse is when the moon looks red, and that's when the Earth casts a shadow on the moon. So if the sun is over here, and then the Earth is in the middle of the moon and the sun, the Earth could cast a shadow on the moon if everything's lined up perfectly. And that's called a lunar eclipse. We also have a solar eclipse, which is when the moon can cast a shadow on Earth. Another way that the moon can affect Earth is with tides. So because moon has a gravitational pull, it could pull the tides up a little bit, pull the water up, and that's what creates the high tides. And that's about it. So hopefully this all made sense. Please go through that Nearpod. There's lots of great stuff in there. Thanks for tuning in. Bye.